Hi everybody, this is Eduardo Suarez. In this video, we're going to look at vision mastering. Vision mastering is a way to improve the result of the manual mastering of the robot, and accurate mastering will result in an accurate vision process. In the manual mastering, the witness marks on each one of the axes of the robot are aligned by manually jogging the robot, and then the mastering is executed. Since the manual mastering relies on the skills of the person that is doing the mastering to perfectly align the witness marks, there is a chance to introduce an error. Vision mastering, on the other hand, uses a camera to look at a target at different angles and is an automatic process done by the robot. The result of the vision mastering will update the master counts and will provide a log file with a correction error on each one of the axes. We're going to start by getting the manual. We're going to go to phantomcamerica.com. We're going to go to eDocs, and on the search field, we're going to look for IR calibration. And the manual we're going to get is the IR calibration operators manual version 4.2. And in the manual, we're going to look for chapter number 4, vision mastering. Here I have the work cell I have already created. We're going to open the teach pendant. We're going to go to status. We're going to go to type. We're going to select version ID. And on next, we're going to select order FI. And you're going to see here that I have installed the option package IR calibration vMaster. That is the J992. For the vision mastering, we need a camera. We're going to install the camera on the inner arm tooling of the robot. And the idea here is that the center line of the camera lens needs to be at least 100 millimeters apart from the center line of the axis number 6 on the robot. And the other thing is that we need to have at least standoff of 400 millimeters. IR calibration is very restrictive on the camera selection. If we are using the R30IP Plus robot controller, the camera needs to be the COWAT SC130EF2. For other controllers, just refer to the IR calibration manual. So in this case, if we select our camera, we're going to have the settings. We have the COWA SC130EF2, and we're using a focal length of 12 millimeters, and we have a standoff distance of 800 millimeters to the calibration grid. The camera needs to be installed properly secure, so it's not going to move during the vision mastering, and also needs to be installed in such a way that it's not going to be on the way or it's not interfere with the movement of the robot. For example, in this case, we shouldn't install the camera on the other side of the robot if the axis number 5 is going to move in this direction, because we're going to bump the camera. The target is going to be the calibration grid and need to be installed with the 3 dots representing the x-axis direction facing up on the camera. And the field of view of the camera needs to be centered as much as possible with the center of the calibration grid. We're going to look now at the vision mastering process. There are 2 types of vision mastering, with and without the gravity compensation. The one we're going to look today is without the gravity compensation. Vision mastering only masters joints 2 through joint 5. It doesn't master joint 1, neither joint 6. We're going to open the teach pendant. We're going to go to menu. We're going to select utilities, and we're going to select IR calibration. You're going to see here, this is the screen for IR calibration, and we're going to select Vision Mastering, and we can either press Detail or we can press Enter. Here you're going to see the screen for the Vision Mastering. We're going to select the robot group. In our case, it's going to be robot group number 1. We're going to select the number of measurement posts. In this case, we have 27. And if we go to choice, we can select between 27 or 8. If you want to reduce the timing for the Vision Mastering, you can select 8 instead of 27. For the work tool frame number, this is going to be a temporary user tool that's going to be used for the calculation of the Vision Mastering. We need to select a user tool that is not going to be used for any other purpose, otherwise you're going to override it. In our case, we're going to select the default value, that is number 9. Then we're going to select the Create Program, and on Create Program, we're going to press the Select. Here you're going to be presented with the screen for the program. We're going to select the camera type. In our case, if we are using the R30iB Plus robot controller, the camera type is going to be IR Vision camera. It's going to be the Kowa SC130EF2. And over here you have options to select the camera that you want to use depending on the robot controller that you have. So once we have selected the camera, one more thing that we can do, we can go back, and over here we can press Display Image, and what you're going to see, that's going to split the screen into panes. On the second pane you can see, you're going to be able to see the camera. So we're going to go back to the Create Program, and over here we need to select the focal distance, that in our case is going to be 12 millimeters. The grid spacing, that is going to be 30 millimeters for the calibration grid. And over here you will have the exposure time. Once you can see the camera on this time, you can update the exposure time to the proper value. You don't want to see the image overexposed, and you don't want to see the image underexposed. So what you can do, you can go live over here, and you can change the exposure time with these two options here, time plus or time minus. And if you want to increase the value anymore, you can press just Shift and time plus and time minus. The image trimming that you have over here, in the case of the Kowa, this is a high resolution camera. So every time it takes a picture, the timing for processing the image is going to be very long. If you want to reduce the timing, you can increase the value for the image trimming, and you can select, for example, 50%. Now we're going to select the reference pose, and in this case it shows uninitialized. What we want to do, we're going to select over here data. We're going to go to the position registers, and I have in here two position registers. One is going to be for home, and the other one is going to be for the Vision Mastering reference position. So we're going to select this one in here, and we're going to go to that position. Shift, move to. And in our case, the Vision Mastering reference position is the same as the home position. So now what we can do, we can just select the reference position and press Shift and record, and the reference position is going to show recorded. So this is going to be the start position when we run the program for the Vision Mastering. We're going to select now the measure camera position, We're going to select again the camera. And one thing that we're going to do, we're going to reduce the speed. So we're going to go to select something like a 30%. And we're going to press Shift and execute. And what you're going to see is that the camera start moving and start taking pictures. You can see here that you want to be all the time with the calibration grid on focus. Okay, now the process for the measuring camera position is done, and you can see here the camera position and the calibration grid position. On step number 9, you can select the sweep angle for the yaw, pitch, and roll. You can increase the value or you can decrease the value if you need to restrict the movement of the robot. In our case, we're going to keep the default values, but the bigger the angle, the more precise is going to be the result. Now we're going to go to step number 12. That's going to be create the program. And in this case, what we're going to do, we're going to press Shift and execute. And you're going to see that the program was done. You're going to have in here the evaluation index of the program. This is just an index that is representing how good the result is going to be when you run the program. The number that you're going to have in here is less than 4.2. If you have a value bigger than 4.2, you might have to reconsider the values that you have for the swing angle. Probably you might have to go with a bigger number, or the other thing you might have to do is increase the stand of distance to the calibration grid. When the vision mastering program is created, it's going to create two programs or two files. We're going to go to select. And you're going to see here that we have the program vmaster11, and we have the other one is vmasterdata11. There are two numbers. The first digits represent the group number for the robot, and the second digit represent the payload number. We're going to go back to our IR calibration, and the thing that we're going to do now is going to go preview. We're going to select the run the Vision Master 11. We're going to press select, and over here we want to keep the speed at 30%, and what we're going to do, we're going to press shift and execute. So it's going to start executing the program. You're going to see now that in the RoboGuide it changed the user tool to user tool number 9. We can see here the calibration grid. This process is going to take some time because it's taking 27 positions. The other thing you have to keep in mind that you need to keep press the shift button all the time. The moment you release the shift button is going to stop the program. So now the program is finished. We need to go back to menu, utilities, error calibration. And the next thing we're going to do, we're going to select update master counts. We're going to press select, and we're going to press shift update. And you're going to see here the compensation angle. In your case, in the real world, you're going to have some different values. We have in here just the J3, that's 0.01. And again, the evaluation for the program needs to be smaller than 4.2. If you have a bigger value, you need to go back on the setup screen, change the swing angle, and generate the program again and run it again. We're going to press preview, and we can go now to the view result. We're going to press select, and we're going to go to the next page. And on the next page, you're going to see now the master counts. You're going to have the original values, and you're going to have the new values. And on output, you can output the files to an external device. We're going to go back to preview, and now you can select the view update log, and on select you're going to see the result for the timestamp for the update log. Just a reminder, if you want to see the master counts of the robot, you need to go to menu, next, system, variables, and over here we're going to be looking for the MR group. We're going to press enter, we're going to press enter again, and we're looking for master counts. And in here you're going to see big numbers. In conclusion, I'm showing here another tool that you can explore. If you want to do the vision mastering, you will need the option package IR calibration vMaster plus a camera. This might be a significant investment just for improving the raw mastering. One more thing that you can do, you can add the gravity compensation to the mastering. That would be the case when you have a very heavy payload and you need to improve the position of the robot. I haven't covered gravity compensation in this video. That would be a more advanced topic. I will leave the link to the work cell on the description below.